For example 11, find the derivative of f of x equaling x cubed at x equals 8. We're going to actually do this a couple of different ways. Let's go ahead and do it first like this. We're going to use the delta x definition, and it's just basically the slope of a tangent line using the limit process to take the secant line closer and closer to the tangent line. And then let's just see how it differs from using the alternate definition as x approaches a. What's our a value here for this one? It is, I believe it was 8. Okay, yeah, we can handle this. So step 1, I'm going to write f prime of 8, finding the derivative of our function at x equals 8. That should be equal to a limit, and instead of using a little h thing, we're going to use delta x, approaching 0, of, and now let's write our difference quotient first, f of 8 plus delta x minus f of 8 over delta x. Once again, all I did was I used this as my blueprint where my a value was equal to 8. Right, and now it's time to just plug this stuff right into the function there in order to have something to take the limit of. So limit as delta x approaches 0 of the quantity 8 plus delta x cubed minus 8 cubed. I'm not even going to compute 8 cubed because I don't think I'll need to. I don't know, we'll see. All over delta x. All right, it seems simple enough. And as we've seen before, what would happen if I were to stick in a 0 for my delta x? If I plug in a 0 here, this is just 8 cubed minus another 8 cubed, that's 0, a 0 over 0. It's indeterminate, and I have to fix it. How do I fix it? Well, it looks like I have something that maybe I can expand out, and maybe things will cancel conveniently, right? So to expand this out, it's based on this. From either algebra or pre-cal or whatever, it is a plus b to the third power. And remember, this is based on Pascal's triangle with a row 1, 3, 3, 1. You take the first and you cube it, a cubed. Plus, now we have 3. We actually had a 1 on this one, but who writes that? Nobody does. 3 times a squared, its power starts decreasing, times b, b's power start increasing, plus 3, that's this next 3 here, times a to the first, b squared, and then finally plus 1, b cubed. So I'm going to do that with these terms inside here, okay? All right. Hopefully there's enough room. There's probably not. Limit delta x approaches 0. I would have 8 cubed plus, I need my coefficient of 3 here, 3 times 8 times delta x, well, that's 8 squared, sorry, plus 3 times 8 times delta x squared. And then the last one is 1 times a delta x to the third power. And then finally, minus 8 cubed. All of this over delta x. Now you can probably see why I didn't cube out the 8, because it just disappears. Does anything else disappear? Doesn't look like it. However, it does look like everything has a common factor of delta x, which I'm going to factor out right about now. Limit delta x goes to 0. Let's see, that would be 64. 8 squared, 64. And then 64 times 3, 8, 180, and 12, 192. I've got 192 of these delta x's plus, let's see, 24, just 24. 24 whole little delta x's squared. And lastly, just a delta x to the third power all over delta x. Now, of course, I could just go through here and cancel out one of the factors of delta x. I am encouraging you to take that in 2 steps, though. Actually factor out the delta x separately so that you don't mistakenly lose one of them. So factoring out delta x across the top, I got 192 plus 24 delta x's, and then plus a delta x to the second power now over delta x. Lovely. Look at this. Cancel, cancel. And now we can go ahead and directly substitute in 0 and calculate our limit. So when I plug in 0 for my delta x, that'll be 0, this will be 0, and all we're left with is 192. So what we just found was f prime of 8 was equal to 192. What did we just find? We found on the graph of, let's say, x cubed, maybe I'll sketch something right here, and draw in an x cubed graph, which looks roughly like this. If I were to count out 3 spaces here, 1, 2, 3, follow this up to the graph, it would be up pretty high, of course, and like wherever that is, that slope of that tangent line, super steep, 192. That's what we just found. All right, let's look at it slightly differently. Let's look at it one more time, except for this time, let's use this alternate definition. Let's see how it differs. Let's see if it actually turns out to be any easier, if it's worse, or what. I'm curious to know. Let's switch to maybe green here. Alternate definition. So this time, f prime of 8 being equal to the limit as, instead of a delta x, instead of an h, it's x approaches our a value, and our a value is 8. And we write it as f of x minus f of 8 over x minus 8. Again, one more time. The blueprint looks just like this, where our a value is just 8. All right, and now we will actually plug both of these things into our function, where our function, if you have forgotten, f of x is equal to x cubed. So I'll have limit x goes to 8 of x cubed minus 8 cubed, okay, over x minus 8. If I were to directly substitute in an 8, this is an 8. Man, that doesn't look like it. I'm going to fix that. I'm going to fix that real quick. There we go. If we were to directly substitute in an 8, we'd have 8 cubed minus 8 cubed, 0. 8 minus 8, 0. 0 over 0, just like we had before. Now then, one of the things that I might do is cube 8. And cubing 8, I would have squared is 64. Where's this? Come on, green crayon. 64 times 8, 32. 3 is 48. 52? No, 51. 51, that's it. Okay, 512. So I'm going to take that out, put 512 in its place. Okay, now I get a 0 over 0. I got to fix it. How could I fix it? Well, it is polynomial, and polynomial usually implies what I got to do is factor. I got to factor something, and a common factor should cancel out if I have a 0 over 0. In other words, x minus 8 should be a factor of the top. So one of the ways to get what that factor is, like the other factor that's left over, is just to divide it. So I'm going to do that off to the side here. I'm going to divide synthetically by 8. And then I would have 1x cubed, 0x squared, 0x, and then minus 512. All right, bring down my 1, multiply 8. Bring down my 8, multiply 64. Bring down my 64. 64 times 8 we just discovered was 512. Very convenient. Which means it divides in evenly as we probably expected. And we get the limit as x approaches 8 of this quotient that's left over after we divide it. It is x squared plus 8x plus 64. And now look, we have resolved our indeterminate form, and we can directly substitute in our 8 for our x's. So this should be equal to 8 squared plus 8 times 8 is another 8 squared plus 64, which is another 8 squared, which is 3 times 8 squared. Does that look familiar? Let me see, back up here. 3 times, yeah, there it was. It was 3 times 8 squared, which turned out to be this 192, whoops, this 192 business that was right there. It's the same exact number. What do you know? We still got f prime of 8 being equal to 192. What did we find again? We found that super steep slope of the tangent line at x equals 8, otherwise known as the derivative of that function at 8.